Good morning, everyone, and welcome to today's webinar, Best Practice for Building a Geological Model from a Map. I would now like to introduce Gary Johnson.
Thank you, Michaela. Today I'm looking forward to taking you through the process of building a geologic model from a geologic map. For today's agenda, we will first be visualizing and analyzing the data in Leapfrog. This includes structural data, GIS data, a topography that has been imported, and a geologic map which we'll be using to construct our model. We will then actually walk through the process of building the geologic model in Leapfrog. We'll discuss different ways to share your results, and we'll leave some time for questions at the end. I will now jump into LeapfrogWorks and begin the modeling process. For those of you who are familiar with LeapfrogWorks, this is the user interface. This includes the ever-important project tree on the left, the scene view in the middle where you can interact and view objects in 3D, the shape list at the bottom. The shape list is going to list any objects that are then included in the 3D scene. For example, if I bring in a topography, you can see it then pops up in the shape list at the bottom. The shape list is nice because this is where you're going to be controlling your visualization settings. Whether you want to display a map on your topography, change the opacity, all of the visualization settings are here included at the shape list. We then have some additional options if you click on an object in the shape list in the properties panel in the bottom right. Now I know I mentioned the project tree is very important. The project tree was also designed to match your workflow in a top-down approach. The project tree begins with topographies folder, GIS data, maps, and photos. These are going to be your more common inputs. In the center, we have our actual modeling folders. And at the bottom of the project tree, we have some common outputs such as saved scenes and movies, cross-sections and contours. And we'll walk you through the process of going through the project tree and constructing your model, and then putting some outputs. The first data that was imported into this project to actually construct the model was a topography. The topography was brought in as points via a CSV file, but this could also be a DEM or a variety of different surface types, whether it's an elevation grid or a common mesh format from an AutoCAD program. We also imported some GIS lines in this project. The GIS data was used to actually build the model, which is not always so common, but I like to show that this is a possibility here. Of course, we were using a geologic map to actually build the basis of this model. And so here you can see the geologic map that was used. This includes some structural contact data. One thing to note that this contact data, or that this structural data is on contact. And so these contact locations and structural information, including dip and dipping angle, were used to actually build the surfaces of this geologic model. And I will take you through that process shortly. Now, one little tips and tricks. If you ever have objects in the scene and you wish to eliminate those from the scene and restore them back to the project tree, we have this nice little clear scene tool right here. The clear scene tool doesn't delete anything from the project, it just restores it back to the project tree. Now, if you ever wanted to save what you're looking at in the 3D scene, that's where the Save Scenes and Movies folder comes in handy. You can always right-click and save your current scene. This allows you to always restore back to that perspective. As you've seen, I just dragged and dropped this into the scene, and it will always return you to that perspective. So no worries about having to navigate back to a certain perspective and or having to bring all of those objects back into the scene. Utilize the Save Scenes folder, and this will do it for you. It almost acts as a bookmark. One thing that I think is worth mentioning at this point in the project is that there are no boreholes included in this model. The most common format to actually construct models in LeapfrogWorks is probably boreholes in my experience. But in this project, we don't use borehole data at all. This can be a very huge time and cost-saving step to building a model. As we all know, boreholes can be very expensive, and they can also be sometimes unreliable. And so in this project, we're actually not going to be using any boreholes at all. To build this model, I'm actually going to utilize the geologic map. So the cool little drag and drop function, I'm going to drag the topography back into the scene. You can see that we have the geologic model draped onto, or the geologic map draped onto the topography here. And this is done using GIS data. We have imported a map, and we have now selected the map that has been imported with this project. So from my experience of being in the field and examining this site location, I know that this is a structural sequence where the oldest formation here is going to be the green formation. The next formation, as if we were looking at a strat column, is going to be the pink, followed by the orange and the yellow, then the dark blue and the light blue. So we don't actually have lithologic names here, we're just going purely based off colors. And so the first process, of course, in building a geologic model is going to be right-clicking on the geologic models folder. Here we're going to select the option to build a new geologic model. You will see that we don't have a base lithology column, and it's automatically blacked out saying none. We also don't have any filters applied. In this case, that is actually what we want because we don't have any boreholes, and so base lithology columns actually correspond to your borehole column. So if you have imported boreholes, here you would select which column or lithology column you actually want to use to build your model. Here we have none, and that is okay. You can also designate your surface resolution, which is going to be the side lengths of the triangles that make up the surfaces in Leapfrog. We call our surfaces meshes, but you might be familiar with these called wireframes, for example, where it's a bunch of triangles pieced together to create a surface. And so that is what the surface resolution actually relates to. An adaptive surface resolution allows those triangles to vary in lengths, and it will be higher resolution where you have data and less resolution where you don't. I'm going to leave this as the default with adaptive unticked. You can then see the model extents here, and you can see the bounding box, which actually corresponds to those model extents. And so if I move this bounding box up, you can see the maximum elevation in the Z scale is going to move up as well. This isn't significant here because the topography will actually be used as the upper extent of our model. We can then come in here and name this model. I'm going to name it model from map. You do have the option to enclose other objects. So if you've built multiple geologic models or numeric models in Leapfrog and you want to make sure that you're using the same exact boundary as another model, you can always just enclose an object and choose the boundary of another model. Here I'm going to just accept the defaults, and I'm going to go ahead and press OK. This model has now processed, but if I bring this into the scene, model from map, and if I turn the little eye icon off on the topography, it will disappear from the scene really briefly. You see we now have the geometry of our geologic model built, but if we click on it, you'll see this is designated as unknown. And so in Leapfrog, once you've built a new geologic model, you've set up the geometry of that object, but we now actually have to go in and build surfaces in the surface chronology to actually slice that model into different output volumes. Now, if I went to go and build a new surface in the surface chronology, in this case, we're going to be building deposit surfaces. And we're going to be building those from structural data. But before I do so, we don't have any lithologies to assign here. And this is common if you're building a geologic model that doesn't include borehole information. So what we actually have to do here is we have to go in and add lithologies that we want to model. This is a very common question that I get all the time. And so I think this is a really good time to show this as an example. If you right click on the lithology section of your geologic model and go to open, we now have our lithology segment here. I'm going to go in and manually add lithologies for each of the color codes that we have here. So for example, green, pink, orange, yellow. I'll call this dark blue and light blue. So I'm going to add first, let's call this green. and I'm going to change the color accordingly. Then I'm going to add another, and so on. I'm just going to make sure that the colors actually correspond to the code on that. And one nice thing here is if you did make a mistake, you can always remove lithologies here. You can also rename them. So if at any point in your modeling process you wanted to come back, you can always rename lithologies that you've added. You might have seen in the past that you can't rename lithologies that have been imported from boreholes. So the next color code name I'm going to add is yellow. And I'm going to change that to yellow. Now I will add a dark blue. And I will add finally a light blue. And I like this blue over here. Perfect. So we've now added all of our lithologies to this model. Now, if you've built surfaces in Leapfrog before, you know that the surface chronology acts like a stratigraphy column. And so you'll want to actually build your surfaces or order your surfaces in chronological order that they were deposited and or eroded. For this project, we have 3 different deposit surfaces that I'll build. I'll build a surface contact between the green and the pink, between the pink and the orange and the yellow. We then also have 2 erosion surfaces, which are going to be the dark blue and the light blue. The nice thing about an erosional surface in Leapfrog is that it allows it to cut through older lithologies. And so this is, quite a geologically intuitive process, which is pretty cool. One thing that you might be noticing here, though, is that there's a fault that actually runs directly through the model. And so I'm going to show you a cool way to incorporate fault into your model and at the same time show you a way to save you some time by copying the chronology of one fault block to another. So for the fault here, we have some structural data, which has been imported into the structural modeling folder. And this includes the fault structural data. And we also have GIS data, the fault boundary, which has been added and or imported. Both the GIS data and the structural data here has been imported, but you can actually generate this within Leapfrog as well. And so everything that has been included in this project could have actually been created within Leapfrog except for the topographic surface and the geologic map. My first step to building a new fault in a model will be to right-click on the fault systems folder and build a new fault. Here we'll be building this fault from structural data. We will be using an existing drawing, but here you can see you can actually create a new drawing directly within Leapfrog, placing your structural disks, and then applying a dip and azimuth to those, and azimuth is just the dipping direction. Here I'm going to choose the fault structural data, and I'm going to go ahead and just press OK. So now, if I expand my fault system folder, we can see that we have this fault structural data fault included in here. We can actually rename this, and let's just call it fault. This is now listed as inactive, and that is because we have the option here to add and edit this fault before we activate it in the model. Another thing is that you can always build your geologic model first and then activate the fault afterwards. Here I'm going to show you a cool little shortcut where our 2 fault blocks in this case are going to be very similar. The surface chronology is pretty much identically the same, and so I'll build a single surface chronology within one of the fault blocks, and then I'll copy that over to the other fault block. I'm going to drag the fault into the scene so that we can see it and turn the opacity down. You could see that this fault now is accommodating the structural data that it was created from, but it doesn't perfectly align with the fault outline on the geologic map. And so here we have actually created GIS data for that fault outline, which I will now add to the fault so that the fault both follows the trace or the outline on the geologic map and also accommodates the structural data. To do this, I will right-click on the fault in the fault system, and I will add GIS vector data, as this has been imported as a GIS line. And I'm going to choose the fault boundary on topography. Now you'll see duplicates here of GIS data, and that is because Leapfrog will automatically drape any imported GIS objects on the topography in the Drape GIS Objects folder. This can be really nice if your elevation data in your imported GIS information does not match the project itself, and Leapfrog will actually drape that directly on the topography, assigning elevation information for you. So we've selected the fault boundary on topography, and I'm going to go ahead and press OK. You will now see that that fault perfectly aligns with the fault on the topography. And so we can now move forward. I'm going to actually activate this fault to show you how that will split the model into two separate fault blocks. Activating a fault is very similar to activating surfaces in the surface chronology. And so we can just double click on the fault system, and we can tick the little box right next to the fault, and we can go ahead and press OK. The model will now process. And as this model processes, you'll see we now have model from map fault block 1, which I can drag into the scene. And we have model from map fault block 2. And so now we have two individual fault blocks that have been offset by our faults. I'll go in and just rename this fault block 1, just because that name can get kind of confusing. Nope. And I'll name this one fault block 2. In this project, I'm actually going to work within fault block 2 because this contains the entirety of the surface chronology. So if I drag fault block 2 in, you can see we still have this big chunk of unknown here. And so we're going to go in and use the structural data that we have imported, that we have created from this geologic map, and we're going to build some surfaces from those. And the nice thing here is if I expand my structural modeling folder, you can see that we have named the structural data in individual files according to the contact zones. And so the first surface that we'll be building will be the contact surface between the green and the pink. So I'll be using the green-pink contact structural data. A nice tips and tricks at this stage is, we've expanded quite a few things in the project tree. I'm going to right-click on project tree at the top and collapse all. I like to do this for organizational purposes, so I can just work within a single folder and keep things nice and clean. So we have our geologic model from map. I'm expanding this, and we're working within fault block 2. To build surfaces in Leapfrog, there's a variety of different ways that you can build surfaces. We have quite a few different surface types. We have erosion, deposit, intrusion, vein, and then some more complex surface types as well. Here we're going to be building basic deposit surface types for the green, pink, orange, and yellow lithologies, and then the blue and light blue will be those erosion surface types, which I mentioned allow those to cut through underlying or older deposits, or any surface type actually erosions can cut through. So our first deposit, as I'm going to be building from oldest to youngest, is going to be the contact between the green and the pink. So I'm going to go new deposit from structural data, and our first lithology, which is younger, is going to be our pink. Our older lithology is going to be the green. I'm going to go ahead and press OK. At this stage, you could actually draw your structural data, but here we have existing structural data in the project. So I'm going to go down and I'm going to select the green-pink contacts. Now I'm going to go ahead and press OK. As I build my surfaces, I like to bring them into the scene to just see what I have constructed now. And so maybe if I turn the opacity down on this topography, and I'll also eliminate this fault from the scene by just clicking the little X down here in the shape list. You could see that within this fault block, we now have a contact between the pink and the green surface. One thing to note in Leapfrog is that these surfaces will also be color-coded according to which lithology it will be placing on which side of the surface. Here we have the pink, and here we have the green. That is correctly orientated according to our geologic map. The next surface we'll be building is going to be between the pink and the orange, and so we're going to repeat the same process here in the surface chronology of right-clicking, going to New Deposit from Structural Data, and in this case, our younger lithology is going to be the orange, the older lithology is going to be the pink, and we're going to go ahead and press OK again. Let's drag this over a little bit, and once again, we have existing structural data. I can use the drop-down arrow to select the contact between the pink and the orange. And I'm going to go ahead and press OK again. You'll see that when building surfaces in Leapfrog from bottom to top or oldest to youngest, they will come in the correct lithologic order. This is a good time to point out the surface chronology is treated as a strat column. And so if I double click on the surface chronology, you'll see that there's these arrows here assigning younger and older. And so, as I just mentioned, when you're building from oldest to youngest, these will automatically come in the correct orientation. But if you're actually building from top to down, you'll want to reorder these and order them accordingly. The surface chronology is pretty much a strat column, which is really cool, but it's something to keep in mind when you're building your model. So for now, these are in the correct order, so I'm going to go ahead and cancel that. And I'm going to analyze the surface that I have just constructed. So now we've built our second surface with the orange on the right side in the scene and the pink on the left. What these surfaces end up doing with the color-coded side is sandwiching the lithology between that. So you can see there's pink on this side of this surface and pink on this side of the surface. It's going to be placing the pink lithology between the two. The next surface in our chronology is going to be between the orange and the yellow. So I'm going to once again repeat the process of building a new deposit from structural data. Now our youngest lithology here is going to be the yellow, and our older lithology is going to be the orange. Once again, I'm going to go ahead and press OK. And we're going to go locate that existing structural data. So now this is going to be the yellow-orange or orange-yellow contacts. And I'm going to go ahead and just press OK. And I'm going to drag this into the scene. We could see that that correctly orientates along the profile of the geologic map. Something cool to see is that we only have 2 structural data points added to the surface, and it is still conforming really well and bending really well, I guess interpolating, along the line of the geologic map. Now, if we saw that this wasn't precisely matching the geologic map contacts, we could go in and digitize some GIS or polylines onto that surface, and then you can always edit surfaces in Leapfrog by right-clicking on them and either adding existing data or editing manually with a polyline or structural data. So it's not a black box, and you can always go in and edit those surfaces as you'd like and apply your own interpretations to them. The next 2 surfaces that we'll be building in this project are going to be the dark blue and the light blue erosional surfaces. And so if we go back to the surface chronology and we right click, we'll now be building erosional surface types. Here we don't have structural data for these. We're actually going to be using GIS lines which were imported. So I'll go in and I'll select from GIS vector data. This allows you to choose GIS lines that have been imported as a shapefile, for example. Here I will say we're using the dark blue as the next object in our chronology, dark blue. Our first lithology, which is the lithology that we're modeling, is the dark blue. And this is a nice little tips and tricks. If you're ever assigning contacts and the lithology is actually contacting more than one below, you can leave this as unknown. And so here, our dark blue is contacting, the yellow, the orange, the pink, and the green. And so we're going to just leave this as unknown. Leapfrog will know which lithologies that is actually contacting. So now we can see, maybe if I turn the opacity a little bit down, we now have a surface that is cutting through those locations and conforming to the data that has been added to it. Another little tips and tricks is if you expand the arrow next to a contact surface, you can see exactly what that surface is being built from. You can see it's the GIS outline here, and you can see that that surface has conformed to that. And so I'll go ahead and just turn the GIS line off. You might notice that this surface is cutting through the other deposits, and the nice thing about erosional surfaces is that it will actually allow the output volume to be placed just above that blue surface, and we don't have to worry about any intersecting volumes here because erosions will cut through other objects. The next surface we'll be building is for the light blue surface, the light blue erosional surface. And so we can right click on our surface chronology. We can build a new erosional surface. Once again, we'll be building that from GIS vector data. Here we can go in and select our light blue outline on the topography. Our younger lithology here is going to be light blue, and our older, because this surface is only contacting the dark blue, is going to be the dark blue. So here, whereas the earlier dark blue contact surface had multiple contacts below, the light blue will only be contacting dark blue below. And so if I bring this into the scene and turn the opacity down on the topography, we now have all of our surfaces here. They've all been built. They've all been assigned and color-coded accordingly. And so what we can now do is we can actually activate these surfaces in this fault block. To do so, I'll go back real quick because that was a little fast. You can right-click and open your surface chronology, or you can double-click it. So you can right-click and open. It'll bring up the same box. The nice thing is Leapfrog leaves, as you can see, surfaces inactive until you choose to activate them. Leapfrog works as a dynamic program, and so any changes that you make to the surfaces will automatically reprocess the model. At this point in the modeling phase, you might be just building your surfaces and have not constructed your model yet and don't want to wait for the model to reprocess. So this is a huge time-saving step where you can leave surfaces inactive. You can then edit them and then activate them later on when you're ready to build the model. So within our second fault block here, I'm going to activate all of our surfaces, and then I'm going to go ahead and press OK. And so that has now processed. We have a ton of different things in the shapeless down here. It's getting a little bit confusing, so I'm going to go ahead and I'm going to clear the scene up in the top left of the toolbar. I'm going to go ahead and bring our topography and associated geologic map back into the scene, and then I'll bring now our fault block too into the scene. you can now see that we have actually built volumes. And so if I turn the topography off, you can see our second fault block has been created. If I turn the topography back on, you can see that this aligns very well with our geologic map. So if I maybe reorientate it for a side perspective, I'll turn the topography off again using the little eye icon, and you can see that these correspond very well. So you might be wondering now why we only built a single fault block, and do we have to redo that entire process for the other fault block? And the answer is actually no here. There is a cool little shortcut which I ask you all to investigate, because this can save you a ton of time, in that you can actually right click now on the surface chronology of fault block 2 and copy chronology 2. Now this option is only available if you have already fault blocked your model. And so you can't copy a chronology to another geologic model, but you can copy it to another fault block. So I'm going to choose copy chronology 2. Fault block 1 is the only other fault block in this case, and it's already selected for me. Now before I do that, you can see that the surface chronology for fault block 1 is empty here. And now when I go ahead and press OK to copy this chronology 2, there will be surfaces that then appear in that surface chronology. And you can see these have all now appeared in the fault block 1 surface chronology, and they are all active. If I drag fault block 1 into the scene now, we now have a finished and complete geologic model, which now corresponds to our geologic map. And so this is a nice, easy way to incorporate different fault blocks and save time by copying the chronology to another block. You can also see that Leapfrog has taken into account the other structural data in the other fault block, and so this surface conforms very well to the structural data, of course, but then also the offset of the fault here. So you can see this clear offset of this fault. Now you might be wondering, there's this little empty, and if I expand the project here a little bit over the right, there's empty listed next to one of our contact surfaces. The reason for that being is that because in our first fault block, technically, there is no light blue lithology, and so that this is just listed as empty. We could actually go in here and delete this because this is not being used. I'm going to cancel that for now, but you do have the option to delete a contact surface if you don't need it in the geologic model itself. Now that we have created this geologic model, you might be wondering how you could share this with your clients or colleagues. And so we do have a very friendly and user-friendly tool called Seequent View, where you can share your project and create slideshows to tell a story with your colleagues. I'm going to go ahead and clear the scene, and I'm going to create a new saved scene of objects that I want to share with my colleagues. I want to bring in my topography with my I'm going to drag and drop my topography into the scene with my geologic map. I'm then going to bring in the output volumes from each individual fault block, and I'll bring in the output volumes from the second fault block. Now I'm just going to first show you one of my favorite objects in the toolbar, actually. So up at the top of the toolbar, there is the option to draw a slice line. It looks like a knife with a little green line next to it. This is my favorite tool in the toolbar because it allows you to cut through your model and analyze it. When I do this, I like to press D on the keyboard so that I'm looking directly down on my model. And then I like to cut across. This gives you a nice cross-section perspective of your model, which you can then slide through to analyze the model. Good time to show off this little tool. This can be a really good way to either generate a cross-section directly from this or to just show a certain perspective of the model. I really like this tool. I think it gives you a ton of perspective into the subsurface of your geologic model. I'm going to go ahead and just remove that now from the scene, just using a little X at the shape list on the slicing object. And so I'm going to now go ahead and upload the scene to view. I can name this my map from model, or model from map. That's a little funny. You can add a description if you'd like. In this case, I'm not worried about a description, but you can do so here. And I'm going to go ahead and just upload that. You'll see a little notification panel will arise over here, and that's just telling you that this is now uploading. It'll also give you a little percentage, and once it's finished uploading, it'll actually provide you a link so that you can go directly to that dashboard. And if you're trying to navigate to that, there's the little notification panel right next to your name in the Leapfrog Works interface. And so you can analyze the progress of the upload, and as soon as it's complete, click that link. It'll also give you a little notification once it is complete. I really like this project because I think it gives you a good example of how you can incorporate a nice structural geologic model from using just a geologic map. And geologic maps are very commonly available either on the internet and or can be created from fields mapping. It's a really easy way to build a geologic model without having to pay a ton of money to drill boreholes. And so whether this is just a conceptual model, whether you're building this to win a bid, there are tons of applications for building models from geologic maps without any boreholes at all. And so now we have finished our upload, and now I can just click this link and go directly to my view dashboard. So we're now processing the view. The nice thing about Seequent View is it's a free sharing platform. So you don't have to download any software, and this can be shared with anyone in the world. I've actually shared one of these with, friends of mine and or with my parents. And so it's a really cool way to share data with somebody who might not be as technically savvy in Leapfrog as you are. And this also allows you to tell a story. And so I like to think of all projects as a story. And so how do you convey that message to somebody who isn't that familiar with the project and or possibly to a stakeholder? So here I've actually have this model right here, and I actually have a few slides that have already been created as well. The nice thing about creating slides is that it can tell the story for you, and so that you don't have to worry about reproducing any particular view. Here I've created a slide of this model with the slicing tool on. So if I wanted to, I can just revert directly to that slide, and you can add multiple slides and provide feedback on these. And so if I wanted to step through the process of the model, you could do so. You can add another slide. You can add a title, a description. You can even draw or add a note on the slide itself. Once you've created your slideshow, discard the changes on that. You can then share this up in the top right of view. You can add a collaborator. A collaborator can then create their own slides if they are listed as an editor. And they can also add feedback on those slides. So this can be good for a QA/QC process. You can add a ton of different email collaborators here, or you can also just share this with a link that you can either make public or private. So if I wanted to make this private, this view is now can only be seen by collaborators. And so, a good way to keep your data safe is to always ensure that it is private. If this is going to be made publicly available, you can make this public at the end of the project's lifecycle. You can also now, which is a new feature, publicly embed a view directly on a web page. So whether it's LinkedIn or on your own company's webpage, this will then appear as a video which you can interact with, and it will also contain the slides. And so you don't have to worry about the user on the other end having complete control over the elements. You can always create a few slides and walk them through your story. And so my story is now over. I think we will leave this up for some questions.
All right. Thank you, Gary. We're now going to begin answering the questions submitted during today's presentation. Okay, it looks like we've got one question in from Stanley who asks, what if you wanted to display a map and GIS data at the same time on the topo?
Well, that is a great question and something that I see all the time. And so you might have been looking at this topography and noticed that at different times I brought in the topography and then I brought in the GIS data. And so there are ways to incorporate both GIS data and a map, for example, onto your display of your topography. The way to do this is, and I'll clear the scene maybe for simplification processes and drag just our topography in. So right now we have this, the Sagon Valley map here in the scene displayed on our topography. If I wanted to include another object, of course I can go here and I can include the dark blue and you'll see just those objects. Now, to do multiple objects at the same time, how we would accomplish this is we would create a new view. And so we can hover over the view object in the GIS data dropdown of the topography and select edit views. We then can go and create a new view. So we can name this GIS data and map. And I'm going to go ahead and create that. You will then have the option to display all of your available GIS data, maps, and photos here onto a new view. And so I'm going to select my map, and then you can either drag it over or you can click on an object and move it over with the add. You can then also control the opacity on that. I'm going to leave the opacity on the map all the way up. And I'm going to move over our dark blue outline. I'm going to move over our fault boundary. And then also we're going to move over this light blue outline. Now, one thing to keep in mind is that the order of objects here is going to be the priority. And so if you're using a map or a photo, you likely want that to be the base priority. And you want to display the other objects above that. You can also control the color here. And so we have dark blue outline. I'm going to color that dark blue. We have I'm going to move that down too, just so this is in nice order. The light blue is actually already light blue, which is nice. And then the fault boundary is purple. I'll make that red so it's a little bit easier to see. And so now I'm just going to go ahead and close this out. And so what we can now do here is display this new view and select that GIS data and maps view that we just created. And now you can see that the fault is properly displayed on the topography. If we zoom in, you can also see that the GIS outlines are also there as well. So this is a nice, easy way to control and create new views. These might be friendly if you're creating some saved scenes and want to toggle through a few different objects displayed on the topography. You can create multiple different views to display those objects. That was a great question.
All right, we've got another one coming in from Ashley, who asks, what if your structural data wasn't on contact? And how did you create or import the structural data?
Some really good question. That's also following up from our last best practice webinar for building a complex geologic model. And so this project actually utilized on-contact structural data. The last webinar, we actually used off-contact structural data. And so you might have seen that when you're building a surface, a new deposit or erosion from structural data, this does have to be on-contact structural data. Now, if you wanted to incorporate off-contact structural data, you would use this new structural surface type. This allows you to select a non-contact structural data and also add other data to that. For example, base lithology contacts, if you had boreholes. And so if you wanted to incorporate off-contact structural data, you can just use the structural surface type via building a new structural surface. That is an awesome question. The structural data in this case was actually created within Leapfrog, so I had put this data together previously before this webinar. And if we expand the structural modeling folder, you'll see that there is some structural data here. This can be made within Leapfrog by right-clicking on the structural modeling folder and making new planar structural data. This structural data can then be created in the scene using the edit tool. So if I wanted to click and drag and draw a point right here, for example, you can then add several points to a file and then name that accordingly. So if I wanted to name this, green pink contacts, I could do so here. You can then assign a dip and a dip azimuth, or the dipping direction. So this is a really cool way to create structural data within Leapfrog, and you can place it directly on a surface or topography or on a plane, for example. You can also then, I'll go ahead and discard these, you can also import planar structural data. If you wanted to see what this data actually looks like as a raw data table, we can double click on one of these folders. Let's do all contacts. And you can see that this just has an X, Y, Z, a dip, an azimuth, a polarity associated with it. And in this case, we have a category. You don't have to have a category. That's just was an option here. But very good question. So this was just imported as a CSV from Excel. But once again, they can actually be made directly within Leapfrog via right-clicking on the structural modeling folder and creating new planar structural data.
All right, I think we've got time for just one more question today. So this one comes in from Luca, who asks, I'm starting on a project with a surface topographical map and geologic surface contacts. Just to clarify, boreholes aren't actually required when building a model?
That is correct. So we've gone ahead right here and we've built this new model from map, which I can drag into the scene. Let's remove the topography for that. There are no boreholes at all in this project. So if I expand the borehole data folder, you can see there's nothing that has been imported here. And so great time to point out that you don't need any boreholes whatsoever to build a model. And of course, boreholes can add some extra, interpolation to your data. But if you wanted to add your own interpretations to this data, you can always edit these surfaces by right-clicking on them and choosing to add or edit. So you can still apply your interpretations or add other data to these surfaces, even when you don't have any borehole contact data at all. Really good question.
Great. Thank you, Gary, and thanks for everyone who attended today's webinar, Best Practice for Building a Geologic Model from a Map. If you have any other questions, please contact our technical support team at support.civil@seequent.com.